Greetings. Hey, welcome. Let's look at a physics problem. A 500 gram steel block rotates on a steel table mu k 0.60 while attached to a 2.0 meter long massless rod. Compressed air fed through the rod is injected from a nozzle on the back of the block, exerting a thrust force of 3.5 Newton. The nozzle is 70 degrees from the radial line. The block starts from rest. What is the block's angular velocity after 10 revolutions? What is the tension in the rod after 10 revolutions? So we're required to find the block's angular velocity at 10 revolutions. So we must find omega final at theta final of 10 revolutions. And we're supposed to find the tension in the rod after 10 revolution. B is asking for the tension at the same position. Okay. Now looking at our diagram. Okay, you have that. We'll take that as our thrust force in that direction, making an angle of gamma. Let's call the angle gamma. From right here, well, from kinematics, we know the following. Let's look at question. Let's look at A. From kinematics, we know that the final angular velocity squared is equals to initial angular velocity squared plus 2 multiplied by angular acceleration multiplied by change in angular position, which is the displacement. In this case, it begins from rest, therefore omega initial is 0 rads per second. This reduces to just 2 alpha change in theta. What else do we know about theta? Okay, we know that change in theta is equals to theta final minus theta initial, and the final position we know, which is 10 revolutions. The initial position we do not know. Take that as 0, because we thought it starts at rest. So change in theta is equals to just the final angular position. Therefore, our equation here reduces to omega squared final is equals to 2 alpha theta final. Alright. So from here, if we know this, we know alpha and that. Okay, this that's just a constant 2, which we also know. So if we know this one, it's the only unknown at the moment. So we need to find this one in order to be able to solve for omega final. 2 alpha theta final, that's the final expression. That this should be able to give us our answer for A. So we need to find this. To get this, we will need to use the following relationship, which is tangential acceleration is equals to alpha multiplied by the radius of curvature, all by the length And how do we get AT? AT, we get this from summation of forces in the tangential direction. That will give us our AT. Okay, that's enough summing up the problem. Now let's draw a free body diagram. Free body diagram. Oh, sorry about that. Free body diagram of the block look like this. It's a free body diagram of block. Okay, so in this would be our n coordinate, n axis, which takes us to our pivot point of the center, and all the way from there going all the way there, that will be our radial line with which the thrust force makes an angle of gamma that we called 70 degrees. Well, we called gamma and the angle was 70. Not forgetting that this guy is moving in a circular path. Okay, cool. So what is this? Okay, that's not coming out well. That one is tangential. The t-axis is tangential to the path. Let's just make this big like that. Okay, so that is perpendicular to that guy. So this is the normal, positive is in that direction, normal axis, and that is the tangential axis. Tangential to what? Tangential to the curve or the path of the particle. Okay, what else do I know? I know the thrust force. So I'm drawing a free body diagram here. Thrust force, which is 3.5 newtons. So this can be broken into components. You can get a tangential component and component that will be in the normal direction. So we'll call the tangential component Ft. Just indicate. We'll call this one Fn. This is gamma. What else? Oh yeah, the rod is attached to the block, so the rod exerts a tension force. Let's call it T, tension force. And finally, we have a friction force that opposes motion. So it will be opposing the linear velocity, in our case linear motion. So friction has to do with linear motion. So Fk, that's my friction. Okay. Okay. So from here, from this diagram, we can be able to use Newton's second law and take summation of forces in the n direction and also in the tangential direction. Just go ahead and do it. Summation of forces in the tangential direction is equals to mass times acceleration in the tangential direction. That direction is positive. So we have what? I have Ft. What is Ft? Ft is equals to F sine gamma, and Fn is equals to F, the thrust force, cos gamma. Okay, so Ft minus Fk is equals to m At. From here we can evaluate our At from this equation. Let's call this equation 1. Then summation of forces in the normal direction is equals to mass of the block multiplied by the normal acceleration, or rather let's say centripetal acceleration, where we know that centripetal acceleration is equivalent to normal acceleration. They have the same formula. In this case, v squared over the length. V squared, what else do we know? Well, we know that linear velocity is related to angular velocity by the radius of curvature. So, substituting that in there, we can get that centripetal acceleration is equals to omega squared L squared over L, which reduces to AC omega squared L. Okay, cool. So, summation of forces in the normal direction, we have the tension force, and what else do we have? We have the normal component of our thrust force, Fn. So all in the same direction. So we have Fn plus tension is equal to MAC. Call this equation, we're not done, let's reduce this further. Fn plus T is equals to M omega squared L. Call this my equation 2. From here, you know that's section B of our question, part B of our question requests us to find the tension force. From here we can make T subject of the formula. We say T is equals to, we move this guy, the other side becomes M omega squared minus Fn. Therefore, tension force M omega squared L minus, what is Fn? Fn is thrust force cos of gamma. This would give us our tension force. So if we find angular velocity at 10 revs, we already got our tension in the rod. So from equation 1, let's get our At, shall we? Yes. From equation 1, written as Ft minus Fk is equals to M At. This was equation 1. From here, At can be made subject of the formula Ft minus Fk divided by the mass I know that Ft is the thrust force, sine gamma minus what is my Fk. Fk, well, this is one other part that I did not explain. Let's just quickly explain where Fk comes from. Fk is equals to mu k multiplied by n. Alright, so what's multiplied by the normal force? Alright, let's just quickly discuss this. So our block is spinning on a table. This is our block, and there's that air being pumped into the rod and then comes out at an angle. So it's on the table spinning. If I isolate the block, then I'm able to indicate the forces acting on the block. It will have a tension force in, well, because the rod is in contact with it, and then we'll have gravitational force, which is Fg plus mg, and then we'll have as tension force. Then we'll also have gravitational forces perpendicularly down, always acts perpendicularly down. Then we'll have our normal force acting upward. It exists because the block is in contact with the table. That contact force is referred to as our normal force. Okay, so from here, taking summation of forces, this is towards the center. This is where the pivot point is. So this is our normal, and that is our z, and into the board is our tangential coordinate. Okay, so taking summation of forces in the z direction, there is no acceleration. The block is on the table, it's not going up and down the table, so it's not zero. So we just have normal minus Fg equals to 0. Therefore the normal force is equals to Fg, and we know that Fg is equals to mg. Alright, so normal force is equals to mg. That's our expression, which we will use in our equation up there. Where there's Fk, we'll use our found equation. Okay, so this further reduces to mu k multiplied by mg. Alright, cool. So F sine gamma minus mu k mg. This will give us our AT, our tangential acceleration value. So let's quickly evaluate that. AT is equivalent to, say, 3.5 sine 70 minus 0.6. 0.5 is our mass because it's 500 gram multiplied by 9.80. Let's take gravity as that. G is 9.80 meters per square second. Mass is 0.5. Okay, because 500 gram divided by 1000 gives you 0.5 kilogram. So this should give us 0.6978 meters per square second. Okay, cool. So we have that. Now can we evaluate angular speed? Yes, we can. Yes, we can. So A, from our discussion, using this, we're able to explain how this reduces to the following. To explain that, okay? And explain that tangential acceleration is related to angular acceleration with this equation. From here, you can actually write angular acceleration in terms of tangential acceleration over L. So this equation can still further be written as AT over L, that one. So a final, or shall we say angular velocity, equals to square root of 2 AT over length multiplied by that guy. Okay, substituting our values, 0.6978 divided by the length is 2.0 multiplied by, we need to convert 10 revs to radians. So yeah, we multiply it by 2 pi radians over 1 rev. This will give us 20 pi radians. So multiply this by 20 pi radians. Okay. Evaluate this on the calculator. This gives us 0.62 rads per second. Okay, we have that. Now we need to find the tension. Okay, I'll just do the tension here. B. Tension force. Found out that tension is equals to, where was that? Is equals to this. So this is the tension force. Oh, let's just do it here. Okay. Tension force is equals to m omega squared length minus F cos gamma. Know the mass, I know angular velocity, I know the length, I know this force, thrust force, and I know the angle. So that reduces to 0.5 multiplied by 6.62 squared multiplied by 2 minus 3.5 multiplied by cos 70. Right, that should give us 42.6. Okay, that's what I'm getting. 42.63 newtons, which can be, well, can be written as 43.0 if you want to round it off to 3 significant figures. Okay, that's my tension force, and that's our angular velocity at the given position. So Alright, cool. So we got 6.62 rads per second, and I got 43.0 newtons. Thanks for watching. Please like, subscribe if you're not subscribed, and don't forget to share the video. Have a nice day.